All right, we're going to look at how to um, find the partial fraction decomposition when given a rational expression. But basically, a partial fraction decomposition is a way of breaking apart fractions with polynomials in them. What you've simplified before when we were when you were working with rational expressions, you were given something such as 2 over x minus 2 plus 3 over x plus 1, and you were asked to simplify this rational expression, and then you had a result of 5x minus 4 over x squared minus x minus 2. So just imagine that we took these two fractions, found a common denominator, the least common denominator, and then wrote the equivalent fractions, and then this would be the result. Well, partial fractions, we're going to be working in the opposite direction. What was our answer becomes the question. So this 5x minus 4 over x squared minus x minus 2, we're going to break this down into partial components. So we're looking for, or our goal is how to find the parts that make the single fractions, or make the parts that make the single fraction, i.e. the partial fractions. So here we have the question, and now we want to find the parts where what was our question now becomes our answer. These would be the partial fractions. So that's what we're going to be working on in this section. So let's look at our first example, where we have here 3x minus 1 over x times x plus 1. One thing that you want to identify when we work with rational expressions, and we're using this method of partial fraction decomposition, we want to make sure that our fraction is a proper fraction. And remember, a proper fraction is where the numerator is smaller than the denominator. But we're determining that by the degree of the numerator to the variable here, which would be x, and as well as the denominator. So here for 3x, the degree is 1. Now in our denominator, if we were to distribute this x, we have x times x, that would give us x squared. So that would, in our denominator, we have a degree of 2. So this would be, or is, a proper fraction. So we're fine there. Now, if it was an improper fraction, then there's some other steps that we would have to take, which would be first converting that rational expression or solving that by long division. And we may or may not get to that at this point, but right now let's just look at the initial components of how to find how to simplify a rational expression so we can find the partial fraction component of that. So first things first, we want to make sure that our denominator is in factored form, and it is. We have an x, we have a factor of x, we have a factor of x plus 1. Then we're going to write one partial fraction for each of those factors. So let me just write this down here. We're going to write one partial fraction for each of those factors. Because what we're looking for will be the coefficients. And let's go ahead and write one partial fraction for each of those factors. So we have two factors. Because we don't know what the unknown is for the numerator, we're going to call that a. But we're going to say a over x. Plus, we have a factor of x plus 1. We don't know what the second fraction its coefficient would be, so we would call that b. So after that, what we're going to do is our goal is to eliminate the denominator. So we're going to multiply both sides of the equation by the LCD. And the LCD here is x times x plus 1. That's what we're going to do. So I'm going to just rewrite it. You don't have to. I'm going to just rewrite this step again so I can leave some space to write the LCD. So let's go ahead and multiply both sides by the LCD. And once you practice a lot of these, then this step would be, you can eliminate this step and be able to work this throughout, or using without a calculator, using your head to calculate. So on the left hand side, the x and x plus 1's cancel out. We have here 3x minus 1 equals 2. The right hand side, the x's cancel out. We have a times x plus 1 plus the second term, the x plus 1's cancel out. We have bx. Now, how are we going to find a and b? Well, there are two ways that we can work this out at this point. One way is substituting the roots or zeros into x and x plus 1. So what I mean here is, how could we cancel out this a? That's my question to you. How could we cancel out this coefficient of a? Meaning, what could we substitute in this x plus 1 for x that when we add 1 will give us 0? Well, that will be negative 1. So if we let x equal to negative 1, and I want to cancel out this coefficient of a, well, what we're going to do is substitute negative 1 into the equation on each side. So we have 3 times negative 1 minus 1 equals to a times negative 1 plus 1 plus b times negative 1. On the right hand side, we have 3 times negative 1, that's negative 3, minus 1, that's negative 4, equals 2. Well, we know for on the right hand side, negative 1 plus 1, that cancels out, or that gives us 0, and 0 times a is 0. And then we have b times negative 1, that gives us negative 1b. Therefore, our answer for the coefficient of b is 4. Okay, so in essence, when you're talking about substituting the roots or zeros into this equation, basically you're looking at, what would be um, its opposite. Okay, so that we can cancel it out. So we also have, think about x. What x, if I want to cancel out this b, then what would x be? What would x represent? Well, x will have to equal to 0. So going back to I'm going to rewrite that equation again. And because we're going to substitute 0 in for x, what's going to happen is going to cancel out the b, and then it would give us the a coefficient. So we have 3 times 0 minus 1 is equal to a times 0 plus 1 plus b times 0. 3 times 0 minus 1, that gives us negative 1 equals to a times 0 plus 1, that's a, and we know that that cancels out there. So we have a coefficient of, for a, the variable a is negative 1. So now what we're going to do is go back to how we set up our equation at the beginning, and we're going to plug in the values for the coefficient of a, for our variable a and for our variable b. So let's go ahead and write out that answer. We have here's the question, 3x minus 1 over x times x plus 1 is equal to, we said a is negative 1 over x plus b, we said was 4. So we have 4 over x plus 1. So if you were given negative 1 over x plus 4 over x plus 1 and asked to add those together, this would be our result. The 3x minus 1 times all over x times x plus 1. Yeah, this would be our result. But our goal is to take this solution and break it into the parts. So basically, I call this Jeopardy. You have the answer. Now your question has to be in the form of an answer. So we have to go back. So we're working backwards here. Now, I also want to show you another method. I said that we can substitute by finding the roots of our LCD, x and x plus 1. Another way that you can set this up is by a system of linear equations. Okay, so I'm going to show you that component as well. So we're going to go back to this particular point here. How could I set this up as a linear equation? So let's go ahead and write that down. I'm going to put a big or. We can use, or we can set up as a system of linear equations. So we have here 3x minus 1 is equal to a times x plus 1 plus bx. I want to focus on that part because I'm going to say this. At some point in, we're going to do several different questions. And at some point, using the roots method, where we're setting those factors basically equal to 0 to find out what x is equal to, this method will not work. So if it does not work, this is the method that you're going to have to use by setting up what we have here, this equation, as a system of linear equations. So what we're going to do, first of all, let's expand this a, meaning distribute the a, we have 3x minus 1 is equal to ax plus a plus bx. Let's combine our terms. We have 3x minus 1 is equal to ax plus bx plus a. Excuse me, that's a. That is an a. So here we're going to rewrite, or what I want us to do is to factor out the x, because I want us to just focus on the x term. So we have 3x minus 1 equals to, factor out the x for the x term. This is our x term. We have a plus b times x, and then we have our coefficient, this variable that represents our coefficient, our unknown coefficient. Okay, so we're going to say plus a. All right, so now we're going to set this up as a system of equations just by focusing on the coefficient component. So our first equation is going to represent the x term. Let me say this again. Our first equation that we're going to write as a system of linear equations is going to represent our x term, what I have here in this blue. So as we set it up, we're saying here, we're just looking at the coefficient part. You're saying 3 is equal to a plus b, looking at your x term. Then the second equation is going to represent the coefficient component. And we have here negative 1 is equal to a. So this is your system of linear equations that we have here. And didn't we, at the previous method, we found what a is. A is negative 1. Then we need to find b, and this is where we substitute negative 1 in for a, and we have b is equal to 4. So we still have our answer as negative 1 over x plus 4 over x plus 1. There we go.